This is the working Polymaker light box with a rotating logo. Let me plug the batteries in here. All right, check it out. Oh yeah. Can't really tell the light changing colors because it's still in the daytime right now, but it works. So very cool. Let me unplug these batteries. But yep, this is the I say final working deal. Let me tear this front off real quick. Just slides right off like a normal light box, the back plate. Then the inside I have the LEDs just like a normal light box. And then this logo is behind the front plate, actually. The front plate is gonna hold this in place. So I can just take this off. This is what it's looking like right now. This is the Bambu Lab motor. And then this is just my regular Amazon LED string lights. So this is what we're looking like on the final for Hello Joe. This is the final for what we're at right now. Until I do some the smaller, slower spinning motors, much quieter motors. That way it isn't a loud noise whenever this is plugged in. But pretty simple, straightforward. Motor, gear, LEDs, box, gear, logo. Simple as that. I'll show you now in the slicer after banging all this around. We switch to the monitor. So brief interruption. If you could go to shirtle.com/links and purchase any of your items such as Bambu Lab printers, filament, LED string lights you might use for the light boxes, Polymaker filament, my affiliate link here, Vectorizer AI. It is no longer free. You can use this to use my affiliate link. That would be greatly appreciated. Thank you very much. Slicer. Pretty simple and straightforward. We have the box and then the mounting clip. The motor has, I'm using M3 by 16 screws for this. You can use, actually, let me check that. I needed to check that. So you can use M3 by probably 8 all the way up to 16 will be safe for this. So M3 by 8 millimeters or M3 by 16 millimeters, anywhere in between will work for this. Switch back to the camera. I have 3 screws in here. 1, 2, and 3. Okay. So, and then the this will obviously mount over the top of the motor to hold it down. That way it's nice and sturdy. And the gear, it slides right on the motor. This is the front logo. And this is the faceplate. Made the faceplate slide in there pretty far. That way it can have enough friction on there to hold that spinning gear in place. It goes in there almost all the way to the hole, the LED string light hole. Okay. Now, let's get to the fusion. This is where we left off on the first video. Actually, let me get these batteries out the way. Okay. So first video, we left off right here. We got the motor in place. We got the front face plate all done up. And the box pretty much where we want it for the most part. It's a good eyeball. And then down here on the bottom timeline, you can see all the new additional steps that I went through to make this the final piece. So in order to get From here to the final workpiece, this is actually my 4th printed prototype. So I printed like 4 of these boxes, tweaking. It was an engineering, over an engineering effort to try to get this from blocking light on the front. Okay, so first things first, what I did is bring in 2 gears that I had created for this project. So the gears, I actually installed a add-in on Fusion, the spur gear. You can find this on Google, spur gear add-in in Fusion 360. It might actually come default in Fusion, I don't remember. But this is the add-in. You just tell it on a little pop-up. Actually, I can show you that right now. Spur gear, it's already running, so I can just type in my shortcuts. Spur gear. This is the pop-up that it gives you. I watched a few videos on what the best settings were for spur gears and 3D printing. And Product Design Online, he has a really good video on how this works and what the proper tolerances are for 3D printing. So if you want to watch those same videos, it's a Product Design Online with the spur gears. So I used his tolerances and such, and then got the right gear sizes that I wanted to make for this project. And then that's where we are, imported those. Next step after that is, see which one of these sketches is the latest. Okay, the gear. Made some extrudes. Oh, that's the extrudes on the motor. Let me hide this front. Let me hide the gears. So this extrude was for the small gear, and then the small gear hole cut for this. Then let me just go ahead and take it all the way so we can show you where we're at. Unhide all these bodies. Okay, so this is the where I finally ended up. I decided to put the logo behind the front faceplate. That way it held the logo in place without any hardware. I was kind of fighting with myself because I didn't want to put any hardware, like a hole through the back with a bolt to hold this in. I didn't want any extra friction than what is needed, because the more friction you have, the more noises and grinding and rubbing plastic parts that you're going to have. So I did this with the least amount of friction that I could think of at the time. I actually, thinking about that now, I might actually go back and put a piece of wax paper or something on the inside of this hole and see if that quietens down. Most of the noise is pretty quiet right now. Most of the noise is coming from the motor at this point. I don't really have much friction on this. The gears going up against each other are not making much noise at all. Most of the noise is coming from the yellow motor. So that is why I was saying I may do another one in the future with the smaller Bambu motor to drive this. And then maybe if I get that nice and quiet, I can have that permanently up on the wall behind me and rotating, as long as it's not loud and obnoxious. So that's the reason why I put the logo behind the faceplate, because the faceplate will now hold. But let me turn this one, opacity, 50%. Okay, you can see this blue body right here is actually the logo. One of my prototypes that I had, you can see it's here to here. We're at 1.5 millimeters behind the faceplate. My first one was, I think it was like a 0.5 millimeter behind it. So just enough to not rub it, but it was rubbing it because this doesn't sit perfectly 90-degree angle with the front faceplate because gravity and whatnot, of course. So I pushed it backwards a little bit more. It's only a 1.5 millimeter gap, no big deal. There's no light shining through this. I'll show you right now, actually. I need to put the logo on first. Faceplate. Okay, whenever I have this, the lights turned on, well, the fear that I had putting this behind the faceplate was that I would see light coming through this ring. But with the oversized logo, or oversized circle, I should say, the oversized circle right here, it's going a little bit beyond the black right here. So it's tucked. You can see this white body is actually tucked behind this white body. A pretty good amount. It's a couple of millimeters. So that blocks the lighting from creeping through. And I'm not showing my screen. Nice. Let me show the screen. So I made this circle go behind the faceplate. So you can see it actually hides the lighting, any light escaping, because it goes further inside behind that faceplate. So back to the face cam. I thought I was going to have an issue with light coming through these areas, but I have looked at it through the side and no issues with that, luckily. But you can see how this moves back and forth just a little bit. And that's why I put the faceplate on the front, to hold that in place. All right, next, what we did is I had to, let me hide the logo. I had to decide which direction to put these gears. I had flipped this motor upside down and put the gears on the bottom against the back of it, but that also pushed the motor up really close to the faceplate, because I had to make a different mounting system for it. So with it up really close to the faceplate, I thought it was going to block the lighting from coming through right here. So I decided against that after I had already went through all the work to make that happen. So this is, like I said, this is like the 4th iteration of this light box already. Actually, you can see up here on the top, oh my goodness, I'm not sharing my screen again. Lovely. So like I was saying, I did have this gear flipped up against the back and the motor flipped upside down, but that wasn't going to work out because it was going to block light to the front. Luckily, I have enough gap in here that the light will spread above this gear and go through there. So I actually put 2 LED loops or string lights around the inside on this one. Just because I wanted the extra lighting, just in case maybe the light didn't get through it. My headset just turned off. Not that I needed to hear you or anything, but unhide this. Okay, so this is where we're at. I have actually, the only thing that I would say would be a little better right now is if you're going to do this project, if you do utilize all of the Bambu Lab parts out of the Bambu Lab maker kit, you could get away from using 2 power sources. And then you could run both power sources to the LEDs, or 1 power source to the LEDs and to the motor. That way you can just jump over to each other. I decided to go the easy route, the lazy route, and that's why I have to have 2 power sources. I wanted to make the first iteration as lazy and easy as possible. That way, if any of you wanted to make your own similar, you could do something like that. And that doesn't require any soldering or any fancy tooling to get it done. So from here, I'll actually pull this apart and show you how it's working. So the lights, normal light box, plug in the LEDs, works just like a normal light box. Nothing fancy going on here with the lights. But with the motor, plug that in. The motor, just simple as can be, plugged in with a USB cable. It just goes constantly, doesn't stop. This is where you could utilize the power button and potentiometer and such in the Bambu kit. If you wanted to get a little more fancy with it, maybe control the speed. And then with that, this just slides into the hole and into the gear grooves up against this gear. I'll have to re-plug it back in. Yeah, and there you go. Pretty simple. All right. Let me plug this back in and I will give you the final show. And then we can go down in the application hangout for some questions. We plug in the lights, plug in the motor. And there you have it. A Polymaker rotating logo light box. Pretty cool. Pretty sweet. I wish this lit up better in the daytime, but it is what it is. So luckily we got through this in only 2 videos. So if you have any questions, you can let me know in the application hangout. Otherwise, if you're watching this on YouTube, any questions, just comment. And then I will be putting this up. I will be putting this model up on my website on shirtle.com. And then any of the components, you can grab the components from here, Bambu Lab. This takes you straight to the Bambu Lab website. Okay, make sure I'm showing my screen. Maker Supply right here. And this is where you can buy the individual parts. This is the motor that I used in this project. Only thing other besides this motor is the LED strip and 3 M3 screws. Those are the only things required. I mean, obviously you need a 3D printer, but this is the only motor that I used. 3 M3 screws, LED string light, and that's it. So I'll also have the LED string lights that I use also on shirtle.com/links. So, yep. Thanks for watching, and then we'll see you next week.